Welcome everyone, welcome. Let's happy Halloween. As you can see, we take it very, very seriously. So if you are into Halloween, you are in the right place. If you're not, maybe you will start after today. Welcome to class 6 of our Introduction to Security. Also, welcome internet. I hope we are live. Can we check someone if we are live? Later, okay. Hopefully you are there, so welcome. Before we start, we have a lot of costumes and parade, and Seba always wants to do a parade, so I will start with introducing our fair knight on a dragon of sorts. Then Star Wars character that I forgot the name, but he was really, really good. Or bad, depends on your order view. Every good show needs to have a good joker, so there it is. And then the thing and the companion. Where's the thing? Oh, here. You can see that we have everything. And finally, last but not least, our angry biker. So yeah, as I was saying, happy Halloween and welcome. Today we will come back to the attacking side of our class. As you remember, 3 weeks ago, we were doing exploitations. You were discovering how to get into a device, and today we will do the step afterwards. So we will see what can we do after we got the initial breach. In particular, there will be privilege escalation, gaining persistence, and we will also look at some side channel attacks. Before we start, the usual table with all the links. Hopefully, you all have all of that already. Results of the survey. Thank you everyone all 20 of you who responded. It seems that it was quite okay. If it's too fast or too slow for you, please go and vote at the end of each class so we can adjust better to your preferences. And now it comes the time for the Pioneers Prize. So it was the assignment number 6. On the 3rd place, getting this multifunctional clock that can be, I assume, programmed, is going to Luboslav. Are you here? If you are not here and you are watching online, it can be collected in future classes. Place number 2, and the award is Raspberry Pi Pico 2, and it goes to David. David, are you here? There you go. Congratulations. It's the first trick or treat of today. Congrats. And the winner and the proud owner of WaveShare RP20401 is going to be Jan. Honza, are you here? Come on. I don't know which one of that. Yeah. Thank you very much. I hope you don't have that already. Maybe we can open a black market for that. Congratulations. Okay, so thank you everyone for playing. If you are still working on the assignments, don't worry, they will stay open, some of them, for a while. Which brings me to the Parish notices. So a couple of announcements. First of all, for CTU students, the class on 21st of November will not be happening in this room, but in the room 301, which is upstairs. There's going to be a robotic challenge happening in here for high school, so we need to move. For online people, nothing will change. You will still have access to live stream, and everything should be working as usual, so no changes there. We will do a couple of reminders of this in the future classes as well. Now, 2 assignments. Assignment 1 has been stopped yesterday, so those of you who didn't manage to do it, hopefully there's none, you no longer can. And word of warning, next week we will stop assignments 2, 3, 4, and 5. So if you didn't do them, I suggest to focus on it because we will stop the containers and it will be no longer possible to finish those if you still have not. And for online people, as usual, make sure that you pull the last changes in the Strato Cyber Lab and then started the class number 6 so you have access to all the cool things that will be happening today. Am I forgetting something? Cool. Okay, let's get into class. First thing that we will be... Oh, sorry, I have a little bit of cold, so I will try to minimize the coughing in the microphone. Apologies in advance. So, first topic of the day is side channel attacks. What is it? Anybody can tell me without reading it, actually? What is a side channel attacks? Have you heard about it? No, no one. We have cool glow-in-the-dark Halloween-themed keychains today for whoever is participating, so definitely worth the price. So side channel attack is a type of attack or vulnerability that aims to gather information from a system or somehow influence the system by exploiting some indirect effect of the system or its hardware. So it's not the primary, like the functionality of the system, but something that is happening while the system is being used. And if we can cleverly use it, we can take advantage of that. There is a nice diagram to illustrate that. So imagine that we have something that has been encrypted and we want to decrypt it. So the most obvious way would be to try to decrypt the algorithm. The second option, because sometimes that might be too difficult or impossible or we don't know how to do that, is to take advantage of some side channel information, notice that something is happening while the encryption is being done, and use that to get to the secret word. We will see some of that today in a hands-on demo. There are a lot of types of side channel attacks, or the signals that you can measure in order to get into the information. There is you can measure some electromagnetic waves, radiation, and so forth. You can use acoustic. That's actually one of the early ones was during the Second World War. Someone in Bell Laboratories noticed that when the encryption machine is doing its work, it sounds weirdly, and this person was measuring it and was actually able to decode the messages based on this information. So this was how it started, and from that it took on, and now we have a lot of policies on how to do stuff so this cannot actually happen. There's a lot of research in this. We can monitor the power usage, power consumption of smart cards, of different devices while they are performing the encryption, and then changes in the power usage can provide us with information how the algorithm works, or rather what is being encrypted, and we can use it for our advantage. And probably the most famous one, and actually the one that we will be trying in a minute, is timing. So we can measure the response time of the system and infer from that what actions are being performed in the system, and use that to decode or get access to very interesting things. Which brings me to our first demo of the day, and I want you to look at the code in the screen. It's a basic function that checks if a password is correct, so we can assume that this is something that will be running in some service that requires login, and this is the method that will be used to check if the provided password is correct. Look at that and try to think what is wrong with that, and possibly how we can take advantage of that. Any ideas? What would you do differently, except for not coding in Python? Yes? Okay. Yeah, I will Okay, I will repeat for the recording. You are very right. Here is a keychain. Thank you for participating. The answer was that we can exactly know how long the password is, because if the incorrect length of the password is provided, this will return right away, which will be much faster than if we go into the next part, which is in the checking of the password with the correct one. There is similar thing in the second part, when we immediately stop the check if we find something that is incorrect. So again, if there is something wrong along the way of the checking of the password, we return. And the longer it takes, the more correct the password is. And this is exactly what we will take advantage of. So as I was saying, let's imagine that this runs in a server, and I would ask you to connect to your Dockers or start your CyberLab and connect. And first, we need to set up the vulnerable server so we can actually exploit it and take advantage of that. So for that, we have a couple of commands. First of all, copy the code from, oh, sorry, I'm not connected. Give me a second. Yes. So first of all, we will copy the code from the data/data to our home folders. That is because you don't have write privileges in the /data, and we will need to write some stuff, so it would not be working for you. Same for the online people. It should be in the exact same location. Secondly, we will start a new tmax for the server. So I will call it side channel attack server. There we are. You can see that the names of the tmax is here in the left bottom corner. That's important because today we will be using a lot of tmaxes, so it's easy to get lost. So every time you can look here and see where exactly are you currently. Now we will install some dependencies we will need. Oh, I didn't connect. Be sure to copy all of it. And before we install the dependencies, we want to be clever, and we will create a virtual environment for our Python so we don't screw up the packages in the system. So this command creates a virtual environment that is kind of sort of an isolated environment for this purpose. And we will install packages there so it will not influence the rest of the system. We are calling the environment the side channel attack virtual environment, which is the parameter over here. Next, we will activate the environment. Probably all of you are familiar with using Python virtual environments, or you are using Conda, so this is not new for you, but anyway. We can see that we have the environment activated, and now comes the time when we are installing the requirements using the Python packaging system. There's a couple of them. Mainly, we need to have the code for the server, and then some dependencies for actually doing the timing analysis. Yes, so please, everyone, wider. Yes. Oh, not here. Sorry, I will do it. Like this? Is it readable? OK. While I'm installing the dependencies, please, if anything doesn't work throughout the class today, raise your hand, tell us. As I was saying, there's going to be a lot of demos. It's possible that something will not work for you. Stop me right away. Hey, it's not working. Then we have people here who can help you. And so you don't get lost and you can still follow what we are doing. OK, we have the we have the dependencies. Let's start a server. For that, we are using a tool called Ubicorn, which takes advantage of the fast API. And we are starting the server for all interfaces in port 8000. Oh, sorry. I will mute myself so you are not. Yes. So if everything goes smoothly, you should see something like that. So the server is starting, and it's waiting for connections. Now, if you see this, this is all we need to do in terms of the server. So we can leave the tmax by pressing Control B and D, as you can see here. And now things get a little bit different for people in here and for people online. Because people online, you are in your local Strato Cyber Lab, so you cannot attack anyone. People in here, you can actually attack each other, which makes it much more fun. So for students in here, please find your IP address. If you don't remember it, it's by running ifconfig. And you should see ETH0. So this is your IP address. You can share it among yourself or in Matrix server if you want people to attack you. And then what we can do is, again, because the virtual environment was activated only in the tmax, we need to, again, go into the correct folder and reactivate it in the terminal that is outside of the tmax. And then we can start the timing attack. So there are two variants. First one, or if you don't put any parameter, that does the timing side channel attack. For comparison, then you can see how much efficient or less efficient it is in comparison to brute forcing. There is also yeah, it should be like this. There is a mode that does brute forcing attack, so you can compare how good or how bad it is. If you don't put anything in this parameter, you will attack the server that you have created. So if you want to attack only yourself, you can run it without it. If you want to attack each other, just share your IPs and put there the IP to be attacked over here. So I will start it. Oh my God. OK. I'm sorry about this. We will do requests. I'm not sure why this wasn't working, but so can I ask you to someone to edit to the document, please? These two commands. How come no one? There's a question. The address is already in use. So you have something from previous classes that is sitting on that address, I would suppose. So either you can start the server on a different port, or try to see if you have something running, stop it, and then run it again. Yes. So if you install the dependencies, you can see that the attack will start. I will go shortly into what the code does. For online people, you have it a little bit easier. You can only attack yourself, so you don't need to specify any IPs. Just run the python3.client for timing attack, or the other one for brute forcing. So what is happening here? You can see that first we were deciding or finding out how long the password is, and for that we are using passwords of different lengths. So remember that in here we know how the code works. It's over here. So first we are taking advantage of the first part of the code, which is checking the length of the password, and we are taking advantage in a way that we are determining how long the password actually is, which speeds up the process afterwards. And once that is done, you can see that over here we found out that the password is of length 5. By the way, upon starting, the server decides random password for you. So if you run it again, it might be different length and different password for sure. And then over here we are starting to deciding, or rather inferring, what is the character of on each position of the password. For time reasons, this password is only consisting of numerical characters, because it's like a little bit longer, as you already saw in the brute forcing attacks. If you have a long password list, it takes a lot longer to actually find the password, and same is for the timing attack.
Does anyone was able to run it and attack others and see others? No, right? There are some errors. I'm not sure. What is the error? No connection adapters were found for, I'm not sure why. OK, we are looking into this.
OK, if it doesn't work for you to attack others, could you start it without the IP password? Let me demonstrate. Can you start it just like this and attack yourself? OK, so sorry, I'm not sure why it doesn't work for you to attack the others, so please try to attack your server that you started. We have now in the exact situation as the people watching online, so you will attack your server. Anybody finished the attack successfully? It can happen that this fails. It's not 100% accurate, and I will explain shortly why. So can you raise your hand if you finished and found the password? OK, couple of people. How long did it take? 40 seconds. So it's roughly similar to me. If you want to compare, if you do the mode brute forcing, you can see that it's trying all the things. In my experiments, it takes roughly 10 times longer to reach the correct password. It depends, of course, on how the random generator is in your favor in terms of generating the password, but roughly that is the ratio. OK, so I will stop it here and see a little bit how the attack is being done. So if I show you the code, we can see that first we have a method that finds the length based on the timing. So what is different in terms of brute forcing is that now we need to measure the times, and it's very good idea not to measure only once, because there can be some fluctuations in the network, that can be other people connecting to you. It might be lots of issues that influence the timing. So what we do is we measure multiple times, and then we compare usually an average of those values. And then once we know the length, we can go to this method, which is at every position tries to find the characters. And it's doing it by trying every position, every character in the vocabulary in that position, measuring the timing, and then if it's successful, it moves on to the next one. So this is the basic idea of the attack. Has anybody's brute forcing finished? Not yet. You can keep it running for a while. As you can see, it's clearly much longer than the timing attack, which shows the advantage of that. The problem is, and maybe some of you will face it, that sometimes the measurements are not very accurate, and then it will fail. So in that case, you need to restart. So it's less reliable, but faster than the brute forcing. Why does it matter that it's faster, or it's even trying less attempts? Can you think about the reason why if we have brute forcing that is reliable, why not just use the brute forcing? Yes? Thank you very much for the answer. I will repeat it. Here is a keychain. Heads up. So the answer was that if we are doing less attempts, there is a less chance for whoever owns the system to notice that there's unusual amount of traffic, and we might be going unnoticed. Thank you very much. Yeah, so this is a very silly demo of how the timing attack works. Usually, it's not working like that in the wild, for a couple of reasons. In here, we had access to the function that was actually checking the password, so we knew exactly what to look for and how to design the attack. Not likely in the wild, right? So this is a little bit simplification for our case. However, there are similar attacks in the wild, and we will see some of those. So most of you probably may have heard about the row hammering attacks. Anybody? Row hammering attacks? Thank you very much for the answer. There you go. Yes, it was the type of attack where we are taking advantage of the fact that that memories are very packed close together, and if we repeatedly access some part of the memory and heavily change the values in there, it can influence the neighboring rows of the memory, as you can see here. So this is the victim row that we are trying to somehow influence. You can think of that as the row which stores a permission to access something. And what we are trying to do is heavily access these surrounding rows, and in hope that because of the design of the memory, this will flip some of the bits over here. If we can influence which bits are to be flipped, we can take advantage of that in the form that we switch the permissions to something that we like. Nice example that is based on some of these issues that are like rooted in the hardware design, where Meltdown Inspector. Have you heard about Meltdown Inspector? It was a big news, actually 4 years ago already. Time flies. So the Meltdown attack was basically based on the fact that the CPU is trying to be faster and faster and smarter, and it's doing it in a way that it preloads some of the data into the cache of the CPU in hopes that then if the data is being accessed, it's going to be faster than if the CPU needs to wait all the time for the data to be loaded. The problem is that sometimes this results in loading data that is not being used because of some branching in the code. And in that case, this data should be wiped from the cache. Sometimes it was not happening fast enough or not at all, and this data could be accessed if it remained in the CPU cache and stolen from there, leading into the situation where the attacker got access to some information that they should not. And the Spectre is a little bit similar, but on the software level. So that is something that we will actually try on our own. So the Spectre takes advantage of something called the speculative execution and branch predictions. So I have a picture here to better demonstrate that. Imagine that we have a piece of C code like that, and there is an if statement over here where the code branches, and what the CPU does is preemptively executing both parts of the branches. So again, it can be faster. And then if the condition over here is being evaluated, the one part of the execution is being discarded. Now, how does the Spectre work? So the Spectre, and sorry, I forgot the important thing, that this decision of whether to execute this part or not is based on some predictor that can be trained or mistrained if we are doing it smartly. And this is exactly how the Spectre attack goes. So first, it accesses the piece of code or the branch which is going into this condition a lot of the time. So you sort of train the predictor into saying, hey, this is the most often we go this way into this condition. So it's a good idea to preload it because it speeds up our execution. Now, once this is done, then we force the code to go the other way. And because of the predictor is saying, hey, most of the time this will be executed, so preload it anyway. And we trick it into loading the data or executing this, and then we can access it by some timing attack, as we saw before. So let's try it in the Spectre demo. Now, I have to warn you that this is dependent on your CPU architecture. So if you are watching online and you are trying it on your devices, you might have slightly different results. For you in here working with the Dockers that we provide, it should be working for you exactly as I will show. So we have, again, a function that is being vulnerable. This is the thing that causes the mishap in the predictor. So we have some array, and we are checking if the provided index is within the array size. If it is, we do some access using this array as another set of indices. If not, we are not doing anything. So this is the function that we will repeatedly call in order to train the predictor, and then we will provide an index that is outside of the bounds and cause leaking of the memory. So go back to your Dockers, and once again we will lead the timing demo, and we will copy the data necessary for this demo from the /data into your home folder. Given the fact that we are working with C code now, we don't need any virtual environment. We will enter the folder with the proof of concept, and we can optionally, I will do it, show the code. Now, if you inspect the code, there is a lot of different options because the authors of this demo try to make it work on as many architectures as possible. But most importantly, we have the victim function over here in the top. Sorry, I will use Nano instead because...
on there?
Yes.
Can we make some stops so they can type?
Yes.
For the online people, was
yes,
pretty fast.
I'm making stop now. Please catch up. If it's not working, let us know. So this is I will go through the code in the meantime and show some important things. So we have the victim code, which I was showing before. We have the array of size 16, and this array is being used as indices for accessing the array number 2, which, as you can see, is much, much larger. And in the other array, we have a secret that, in our case, is these magic words are squeamish something, which I cannot even pronounce. And our goal for this demo is to extract this password from the memory, which we should not access, because, as you could see in the function over here, if we are looking at something that is larger than the 16 points in the array, we should not be led into this part of the code and actually accessing the other array. Okay. Are we good? Yes.
Be sure you understand this one, okay? It's tough, it's not straightforward, so please stop, ask questions, try to be sure that you get the idea, okay? It's hard, because it's like playing with a hardware issue inside the CPU, okay?
Okay, so we have our C code. We will compile it. This by typing make, because we have the make file ready in that folder. And once you compile it, you should have something called spectre out, which is a binary which we can run, and that will do the attack. So this is this command. We will just run it, and you can see that is trying to read. I will make it a little bit smaller. Hopefully you can still read it. Let me know in the back if you're not. You can see that it's accessing different parts of the memory and then trying to guess what is there. You can see that there are a couple of options, and it's providing us with the one that has the highest score and then the second highest score over here. So it's doing some kind of timing attack into in terms of inferring what is in the each of the bytes of the memory. So you can see that in my case, it correctly guessed everything. It's possible that for you, you will have some question marks there. In that case, if it's happening for you, especially for people online, because you might have different CPU architectures, you can try to provide a parameter for running the binary. Usually, range in between 40 and 200 solves the problem. If not, you can try to see if your architecture is compatible with that. There is a link to the official repository of this proof of concept, people who are way smarter than me in terms of CPU architecture. So hopefully there are some additional steps that you can take to make it run. Yes, did you make it run in your macOS? M1 CPU is not compatible with that, which is actually good for you because it shows that it's not not being affected with this kind of vulnerability. As you can see, all of our Dockers and the servers that we are running, the Dockers are. So don't misuse it if you know how. Remember what Vero said in the beginning, do not attack our architecture. The hairy thing can get very, very mad. Okay, so did you manage to run this? Did you? Does it show the password or the secret code for everyone? Did it fail in any of the characters for anyone? That would be more interesting. I tried to make it fail in our server. It was harder than I thought. So, which, again, is not a good sign in terms of our security. There is some mitigations to that. Actually, both Linux kernel and Intel have their own mitigations. It goes into flags during compilations which try to prevent this behavior. TLDR, basically, it reverts on the speeding up of the execution of the code. So yeah, they are slowing down in terms of not forcing this behavior. So this is a real-world example of a vulnerability and how it can be exploited using timing attacks, and which is a form of side channels. There are much more, but the timing one is the most common because it's easiest to do. The other one actually involve measuring other types of side channels. It's fine. Hopefully you're okay. Yeah, but the biggest impact of these attacks are that it's not directly attacking the system, but some of its, like, let's say, side characteristics. So it's very hard to take care of that and to prevent that. Usually, if you want to be really sure, you need to air gap the system so no one can measure any of the sound characteristics, any of the electromagnetic characteristics, and so on. So completely preventing this is very, very hard. And it makes it very hard to mitigate that. Okay, question side channels. Anything that doesn't make sense, is not working? Do we have any online questions? Hopefully not. For Mac and ones, it will probably not work. I'm sorry, people, that you have Mac. No, I'm joking. That you cannot do that. It's, as I was saying, it's actually good for you that you are not affected by this. Okay, so chapter number 1 of today is gone. Side channels, let's leave them behind. If you would be interested in that, I put a link to a full lecture on these two vulnerabilities, Meltdown and Spectre. It goes really, really deep into the hardware problems and how it was caused, how it was discovered, and so on. So if you're into this stuff, please go see it. It's actually very, very cool. Also, link to the repository from which I've borrowed the proof of concept, so you can go and read also the description there. As I was saying, it is quite detailed and technical in terms of CPU architectures. Okay, let's go to the second part, which is gaining persistence. So, as I was saying in the beginning, we ended up in our attacker's path after the initial breach into the system, right? So we did some exploit, it worked, nice. You may remember that we were doing like the Apache exploit, right? We were able to traverse the system, list files there. So that's cool. What happens next, right? So usually we want to make sure that we can do it again, because very often we cannot really do the full scale of the attack in the first try. So persistence is a good way to do this. Why do we want to make sure that we can do it again, maybe in a different path? Well, often people seem to patch their systems, right? That somebody finds the vulnerability, puts it online, says, hey, people, you are vulnerable. Please make sure you patch your system, and your access point is gone. You cannot do that anymore. So it's good if while you have access, you create some sort of backdoor so you can come through a different path again. This can be patching, changes on configuration. Maybe the first method was too obvious, right? Someone was saying that brute forcing might be too obvious, so we might want to look for a more stealthy way. And it's said, but some exploits might only work once, and then you cannot run them again. So how can we achieve this? Well, there's a lot of options. Yes. Thank you. I will.
There is another analogy with physical security. So you know that you can lockpick your way into a door, right? You want to get access to an office, so you have your lockpicks, you get in, but that process takes you maybe like a few minutes, or sometimes more than a few minutes. So you do it once, and then you want to get access to the office again, and then you have to do it all over again. So if you get a copy of the key, well, you just get in every time. So with persistence, it's a little bit of like that. You can hack your way every time, but it's going to be very time-consuming. Or you can get persistence and just get access whenever you want, right?
Yeah, and also similar. I will expand on your analogy. Also, lockpicking usually makes some marks on the logs, so it's kind of something that is easy sometimes to spot, and you want to avoid that. So there's a lot of ways how to get persistence. I'm not sure if we've already mentioned the Mitre taxonomy in this class. If not, there's a link to a Mitre taxonomy, which is a huge taxonomy of methods in offensive security that are classified based on what they are trying to achieve. And according to that, I've taken from a few examples of how we can get persistence. First one is account manipulation, which means either creating an account or somehow changing it so you can use an existing account to access the system. You can change some or add some programs to start upon booting or logon, so they create the backdoor for you every time the device is rebooted. You can use some browser extensions. Everybody's using browser extensions. They tend to have the reputation for not being the safest, so that can be a good way. We have 2 classes on web security, so maybe we will actually go deeper into that. You can create some binary and leave it in the system, compromise some existing binary in the system, such as it provides the backdoor for you. I already mentioned account creating, and there is a lot more things we can do. Scheduling jobs. 2 weeks ago, we were talking about cron, which is the scheduler in Linux systems, so you can use that to repeatedly check if the backdoor is available and reopen it if needed, and many more things. It's really up to your creativity, but there are plenty of tools that we can use. So we will start with a very, very simple one, and that is create a remote shell that you can access anytime. So we will need 2 points. One will be the attacker, the other one will be the victim, and we will try to connect to create a shell that goes to the victim's computer so we can access anytime. And we would like to create this remote shell when we get the first access to the victim's machine. So we already breached the system we are in. Now we want to create the shell so we can come again. So how does it work? We will first start in the victim's computer, and we will open a port using NCAT. You remember NCAT? We have covered it in second class. And then this NCAT will be waiting for connection, and the attacker will say, hey, I want to connect, goes to this opened NCAT, and ta-da, we will have the shell. So first, we need to do some preparations. Now comes the time when we will have multiple tmaxes, so please stay tuned and stop me if I'm going too fast. Firstly, we will create a new tmax called victim. And in that tmax, because now hopefully it will work and you will actually attack each other, you probably don't want other people in the class accessing your router with your Docker with root privileges. So we will create a user called myVictim. Select some password that you remember. Yeah, I know. Oh my God. Clearly, I cannot type. Ta-da! Oof, that was harder than I thought. Yes, we don't need to put the information. The important thing is that we have now a user, myVictim. How can I check if the user is successfully created, by the way? Do you remember where should I look? Yes? Exactly, I can cut the etc/passwd, and we can see that there is a nice little victim user over here. For online people, you need to have you need to take one step further, and there is a Docker in your cyber lab that will be used as a victim. So first connect to that Docker using this password, and then continue with creating the user myVictim. And now, for you guys in the room, we actually want people to attack us. So we will find our IP address. Oh, not this. And hopefully you will share it in Matrix or to the friend that is sitting next to you. So we will be attacking each other. If you want to attack me, this is the IP address that you should use. OK. And last but not least, we need to switch to the newly created user. Because, as I was saying, we will be opening the NCAT, and whoever accesses that NCAT will access it as the user who created it. So if we don't want to share root privileges with our fellow students, it's a good idea to start it as a victim. And how do we open the NCAT for the incoming connection? So the NCAT, you remember, we will use the -L, which means listening mode. So we will be waiting for connection. We will be using port 9000, which I've randomly selected. We will use the parameter -k, which means leave it open, keep it open. And then the C parameter provides the actual shell. So whatever is in the command will be transferred to the person who is connecting to our shell, right? So if I go back to the image, the attacker over here will connect, and nice little shell will be waiting at the end of the connection for the attacker. So let's do that. Remember to be a victim, user myVictim over here. So it should have no output, just stay open like this, because we are waiting for incoming connection. If this is done, we can leave the terminal, and I will make a little pause here for you to catch up and get to the same situation as I am in here. If there are any issues, please let us know. We will come help. Are we good? Yeah, yeah, I will wait. What happened to your dragon? What happened to your dragon? Oh. Everybody open their shells, waiting to be attacked. I will take the silence as a yes. Okay, so let's leave this Tmax by doing Control D B. Oh, Control B D. Sorry. And now we will move. We have our victim ready, and we will move to being the attacker. Once again, we will create a Tmax for that, conveniently named the attacker. And now, if you are here in the room and you have shared your IP with someone, hopefully they also shared IP with you. So you will use encat replacing this placeholder there with the IP that you are about to attack. Once again, online people, you can only attack yourself. So you will use the command over here that will attack the victim Docker that you have in your CyberLab. So I will open element, and hopefully somebody shared IP, which I can attack. Is it so slow, or are you not? Ah, you are sharing here. Perfect. I will choose Honza's IP here. And yes, and do the encat and port 9000. Okay, it has done something. I cannot see a lot, but it seems that there is a connection that has been established. Okay, let's see if I actually have a shell. So I can run the W command, which tells me what? Anybody? It tells me who is connected to the device. I can do ID, which tells me who I am. So Honza, or who was it that provided me with this IP, actually created my victim user correctly. And I can do all other sorts of things, like listing processes and all sorts of things. So it seems that this works quite nicely. The only thing that doesn't work is this nice, like, going up in history and all the fancy things that we have in Bash. But we cannot be picky at this point. We have stable access to the device. We can run stuff. We can execute commands. We have successfully established some persistence in the target machine. So everybody, please connect to your victims. Try to run some of the commands that you have learned in the past. See what is in the system. Maybe there is something left over. You can actually leave something. If you successfully attacked each other, you can leave a nice little message in the system, and so forth. And while you're doing that, I would like you to think what might be some problems with this approach. What can go wrong? How this can be stopped? Okay, thank you for the. I will repeat it for the online people. Maybe can we have some microphones for the answers? Yes. So it was a very correct answer. One of the things that can go wrong, and the main problem is that as the attacker, we are connecting to the victim, and that is quite easily being stopped, like with firewall, right? It's not that common that someone would be connecting to you, to your device. Imagine that you are in a company, and suddenly someone connects directly to your computer. Probably not. I will try to. Sorry. Heads up. Good thing it's light. I might injure someone. Yes. So this is exactly the issue that can easily be the problem of this approach. Another thing is, if the computer reboots, the NCAT stops, our connection stops, our persistence is gone. So it's not the most reliable source of or way to achieve persistence, but it's something to start with. In particular, we can do a little bit better and go around the firewall problem that you correctly described by switching the directionality. So we will do something that is called reverse shell. How does it differ? We still have the victim computer and the attacker computer. Now, the big change is that before the attacker was connecting to the victim, now the victim will connect to the attacker. You may think that this is not a big change, but in terms of the firewalling, it's very common that even if you are in some protected environment, you are going outwards to get to services. You are going to some email client. You are going to read the news. You are going out a lot. So it's not that suspicious. It's not that suspicious, and it's quite more difficult to stop that. How can we do that? So first step is to stop all existing netcuts that are happening. So stop the NCAT in the attacker and reconnect to the victim by A-T victim and stop the NCAT in the victim as well. So no more NCAT running in our devices. Once that is done, in the attacker's TMAC session, we will open the NCAT that will be listening for potential connection, right? So as I was saying, the victim should be connecting back to us. So we need to be ready to receive that connection. So going into the attacker session, sorry. I got lost in my own TMAXs. Yes, I want to do that in attackers. Remember to check the bottom always that you are in the correct one. In attacker, I will open the LCAT, again in the listening mode, in the port 9000, and with the parameter -k, which means keep open. And I will have the same output as before, which is none, because no one is connected yet. And once this is done, I will go to the victim and connect to my prepared attacker's NCAT that is waiting there for me. So again, now choose for the students in here, choose an IP of your friend and connect to them, giving them access in your Docker. Again, make sure that you are still in the victim's TMAX and in the my victim user, so you don't give anybody the root user in your Docker. And for that, you will use this command. It's the same as before. We are using NCAT, your friend's IP, the port, and we are giving the bin bash as a command that is to be run to whoever is at the other side of the connection. So once again, I will choose someone, Maciej over here, and okay, Maciej doesn't have an open. I have a typo there. Oh, Maciej might have an open session for me. Oh yeah, he does. So now, if Maciej, if you are here, if you go to your attacker's TMAX, you can actually list the things in my Docker. You can explore what is there, and similarly, hopefully, someone. Oh, someone has connected to me. Thank you very much, and gives me access to the device. So this is same idea, but reversed directionality. And again, it's not resilient to other problems such as the rebooting of the victim's device, but we have solved at least one problem of being easily spotted as incoming connection and being easily stopped as incoming connection. So one step at a time, we have improved a little bit. Maybe we can improve even more. So what happens if the if the victim machine restarts? Well, we've already seen cron, so we can use a scheduler and try to connect every time the machine boots up. Every 5 minutes we can check, or so we can check if the session is active. If there is no NCAT like that, we can start it and try to connect. So there is a lot of options we can do. If you'd like to see more, there is a very nice GitHub repository over here, which has a lot of options and guides how this can be done, apart from the reverse shell that we have tried today. One another problem that we have with this shell, remote shell and reverse shell, is that it's kind of not being protected at all, our traffic, right? There's no encryption, there's nothing. We can implement our own, but nobody wants to do that. And if you've taken the cryptography class, they probably told you not to do your own encryption. So we can use something that is already working. We can do this through SSH. We can use SSL. We might be thinking, well, port 9000, that's quite unusual. Maybe we can hide in a plain sight and use something more usual, such as 443 or others. Can we do that? Can I use NCAT and open a port at 443? If I'm root, and why is that? Very nice. So I can, in some cases, if I'm being root in the machine, I can do that. If not, I need to be outside of the first 1024 ports. We can also automate this whole process. We will see more in the class number 9, if I'm not mistaken, which will be on malware and command and controls. And we can do other things from the taxonomy that I was talking before. We don't have to do the shells. We can create a user for us or modify a user and just use plain SSH to connect to that. We can also hide the traffic into something that is being commonly used, and that can be, for instance, DNS. DNS can be used for tunneling, and we also might include that in future classes, that there is a lot of DNS traffic going on, so if you can hide the information in the DNS request, and you are on the receiving end of the DNS request, you can use this as a communication channel. And before we go into break, I want to show you one nice functionality of NCAT, which sadly will work only for you in the room, not for the folks online. And that is that NCAT can be used as a poor man's chatting system. So I will create a server, and you can try to connect and chat with each other. So for that, I will be using these parameters broker and chat. Oh, sorry. And I will just first copy my IP here so you can connect. Actually, I'm not sure. Yes, I already put it. Good. So I'm opening the chat over here. And now, if you run in your Docker this command and start typing, you can use my open chat over here to send messages to each other. Of course, everybody will be chatting together, so there are no rooms, there is no private conversation.
You can connect yourself so you can see it.
Oh, true. I will. Not this one. Yeah. So you can see that it's not private conversations, but you can see different users. So at least you know who is sending what. But yeah, so I'm not saying that this can be used as a way of communicating during exams, classes, whatsoever, but it's a nice functionality that Nmap has. Maybe someone can tell us why is it there. Now when I think about it, I don't know why NCAT has this functionality.
Because it's
except for it's being super fun.
It's amazing. I think it's because like historically all the people was using Netcat to do this by hand, and it was very cumbersome. And they were, and then it's okay. Let's put the functionality officially. It was that's it.
Have you been using NCAT in the past dark ages of internet
Cannot
for this?
confirm or deny.
Okay, so this brings us to the first break. So you can keep chatting. I will keep it open. We will have a 10-minute break. So in 3:40, we will come back and start with the next part. So refresh yourselves, chat in our Pursman chat room, and we will see you in 10 minutes. Okay, people, am I up? We will be continuing. So please go back to your seats. Oh. So thank you for sending a lot of things in my chat room. Yeah, a lot of lorem ipsum. So to sum up, before we going to the next topic, persistence is something we do post-exploitation, and the basic goal is to make sure that we can connect to the host machine, to the victim machine again, even if the system is being patched, rebooted, there are some protective measures being taken care of. Still, we want to be able to go back to the victim and continue our attack, continue expanding our foothold. And ideally, we want to do this in a very stealthy way, so it's not being detected easily. Another thing that we usually want to do after the initial exploit is to elevate our privileges. If we are not being root, which is usually the case, it's very hard to get the root access or the administrative powers right after the first exploit. But the real question is, do we care about this? Do we really need root? Well, we have already seen one example when we do, two actually. One of them is adding users, and the other one is using the so-called restricted ports, 0 to 1024. But for a lot of cases, we don't actually care about being root, right? If we want to use resources, abuse it, like miner, do people still mine? I'm not sure. Maybe yes. We don't need to be root. You can do it in the JavaScript in the web page. So why bother doing some extra work into leading into being a root?
So I think that the majority of the attacks are not root, right? Like, yeah, it's more like an old school thing.
I already mentioned the restricted and or privileged and non-privileged ports. It would be nicer to be able to use some of the persistence techniques in the privileged port, but I mean, yeah, it works even without that. A lot of the IoTs, we just want to use the bandwidth. Sometimes we only want to do like a move to other non-privileged user. We usually call it lateral movement, when you are moving to the side and gradually building your way through the system. You can access usually the database without being root, but there are some cases when it's actually quite handy or necessary to have the root privileges. Firstly, if you want to install global, so system-wide programs which are not restricted to your user, if we want to do any modifications to the kernel, we've already seen case where we need root, and that is sniffing packets. So if you want to know what's going on in the network and sniff packets, we need to be root. Restricted ports, we have already mentioned. And it helps, and we've covered that in the class 2 weeks ago when we were looking at traces. If we want to delete them, in some cases, we need to be root. We will see today that there are cases for which we don't need the root privileges, but it's easier if we do. And I've already mentioned that, but to repeat, if we want to add users, which is a nice way of adding persistence, especially if we have a system that has a lot of users, it's kind of easy to blend in and have our user there, which we can use for coming back later. So how do we do that? How do we become root if we are not yet? As with majority of attacks, the key is to have good understanding about the system. So versions, we've already seen that if you know versions of services and tools, you can go online and search if there is any vulnerability that can help you. That goes for the programs. What are the users? What IPs are being used? And is the system like connecting somewhere, or are people connecting to the system? Most of the times, it's some local misconfiguration. So somebody misconfigured something, and maybe long in the past, nobody fixed it afterwards, and we can take advantage of that. And one of the examples of that is so-called SUID binaries. So anybody has heard about SUIDs? OK, so what are they? It's a special bit in permissions. So you remember permissions. We have the right to writing, reading, and executing in the owner, group, and the rest of the world. There's more. And the more are 3 more bits. One of them is set user ID. The other one is set group ID. And the last is called a sticky bit. The set user ID, if it's enabled, whenever a process is started using the binary that has this set user ID bit enabled, the process is started as the owner of the binary. So not as the account that is starting it, but as the owner of the binary. The same for the group. I set group ID, and the sticky bit actually just modifies if files can be deleted in the directory or not. It's not very important for getting root privileges, so we will not get deeper into that. So it's a little bit strange concept, right? Why would I want someone to start a binary as the owner and not as themselves? So the best example is if you are trying to change your own password, right? We've seen that in order to access the etc/shadow, where the passwords are actually stored, you need to be root. But as your own user, you can change your own password. So you need to be temporarily allowed to go and modify a file that you should not touch in any other circumstances. And that's one example of the case where the set user ID can be actually very helpful. Here is a diagram of how does it look in the permissions. If we are setting permissions, we have the owner, group, and the rest of the world. And before that, we have the 3 bits that are the set user ID, set group ID, and the sticky bit. I am not sure if we have covered the numerical values, but you may already know that instead of the letters, we can actually use the numerical values that are listed over here in the top. It works exactly the same. The benefit only is that you can sum them up to set the permissions faster. But in my opinion, it makes it a little bit less readable. So for the rest of the class, we will stick with the letters. OK. So there, I've already mentioned the passwd, which is the command, the binary that actually lets you to change your own password. There are more that have the same set user ID bit enabled. Sudo, again, switching users. If you are switching to root, you need a mounting and unmounting and other things. There is only few of them in the system, and the reason is that it's very dangerous. If there's any issue with any of these, and those are usually owned by root, so if there is any problem with those and you execute it as root, it can be a nice way to become actually root and take over or elevate your privileges to the root. So how can we look for them in the system? There is a very nasty find command over here, so let's break it up into pieces. First of all, we tell the find where to look, and we put slash there, which means look everywhere. Start from the root. Start from the root and look everywhere. Now, this the -p means that we are looking for files where the sticky bit is enabled, right? Those are the important ones. The dash type F means that we are only looking for files. We are skipping directories, and execute the ls.la so we can see all the privileges of the permissions of the file. So let's go to our Dockers. I will close the chat room and run the command. And you can see that, yeah, there's a couple of them. Most of them we have already covered. We have more, but all of them have the same property, and that is the sticky bit. Yeah, if you would be, unlike me, fan of the numerical representation, there is a alternative for you. But as I was saying, I will prefer to use the letters instead of that. So how do we set the user ID bit? You guys in here, you already have the user my victim. For you people online, please in your hacker lab add user my victim so you can locally try stuff with the privileged and unprivileged user. And once you do that, we will try and create our own binary that will set the user ID to something else, then we run it. So we will see how does it work. So for that we will need to create a file with this content. So use your favorite text editor. I will use Nano, and copy this very small piece of C code into it. So basically what it does is sets the user ID to zeros. Do we know anybody what is the user that has ID 0? Awesome, it's root. And then it will start a shell in the system. So in other words, this line switches user to root, and this line starts a shell as the user, which now it's root. So yes, I have the lot of things, but among others, I have the C file over here. You have probably remembered the agents from the assignment. Now, we have the C code. In order to turn it into binary, we need to compile it. So this command over here, and we want to output it as the SUID example. Oh, sorry, I didn't copy it. Yes, there are some warnings. I will ignore them. They are not important for this demo. So please compile the the C code. And last but not least, we need to make the root the owner because of the setuid property. Remember, whoever is running the binary runs it as an owner. So we need the owner to be root. For that, we will use a tool called chown. And then we need to add a couple of permissions. First one is making it executable. And the last one is actually set the setuid bit to enable. OK, I'm pausing here, letting you catch up. Yeah. Well, in case you were, actually, this is you are right. It's a redundant line because we are creating as root. There's a good point. If we, in some case where someone else, we would switch to root, but you are very right, and for that you get a spirit heads up. I'm getting better at this. Almost. So yeah, this is a little bit redundant because we have already created the file as a root. Okay, everybody managed to compile that? No problems in the compilation except for the warnings, which we ignore. Good. So next thing is we will switch to the victim user, so someone who doesn't have the root privileges. as you can see, also the terminal tells me that I have switched. Just to be sure, I will run the ID command, which tells me who I am and also to which groups do I belong. And now comes the time when we actually take advantage of the nice binary that we have created for ourselves, and we will run it, which, if you remember, and I will show it over here, we set the user ID to 0, which equals root, and then start shell. So what we can see here is a nice shell, and if I repeat the ID command, we see that the code actually does exactly what we wanted. So right now I am root, so I can access all kinds of things, such as the password files and so forth. So this is the very teeny tiny example how the setuid binaries work. Now let's see how we can find them in the system and how we can actually use it rather than compile it ourselves, because in this case, we were root and we created the binary for ourselves, which we later exploited. Of course, in the wild, you would not do that. You would be finding your way into a system, and then you don't have the root privileges, right? We are trying to get them. So you would have to search if there is any binary that has some of the setuid bit enabled, so we can use it to turn into root. And for that, we will use a nice tool that is called PEACE, which is an acronym for Privilege Escalation Awesome Script Suite. Right now it's called PEACE NG because it was designed originally only for Linux, but now they have expanded. And the nice thing about this tool is that we don't need to install it. We will just take this command and use it as it is. So what does it do? What does it do? It goes into GitHub and uses curl to take this script from the GitHub. You can see that it has a shell script, and then pipe it into a shell. So please exit here and use the code, and then you will see a lot of information. It will generate basically a report of the system, and it searches for all the possible things that can be used to get the elevated privileges. So it will go through all the directories, it will go through all the files, it will check all the permissions, and it will suggest where to look for the potential candidate to help us into the root privileges. So I will let it run. Also, please do. It will take a little bit. If for some reason it's not running for you, there is a sample report. How does it look? So you can access those, but please try to run it so you can see it in your own system. And I will make pause for questions. Also, can we please check Element if we have any questions there? All good. All good, or everybody's asleep? Hopefully the first option. Okay. Is it also running long for you? Maybe we have some internet issues. Oh. Okay. So, as you can see from the header over here, it has some legend, and it marks also the information provided for you as in terms of how likely this can be for you to use it to do some of the steps towards being a root. So we will be mainly looking at these two that has like a very high chance of being a privilege escalation vector or something that we should take a look. So one of the things is, which you might not see actually, because I realized that this is a demo that we will do in a minute, but sudo version, as I was saying before, versions are very important, and it's always a first good step to look at all the versions in the system. There is something over here in the my victim. Also, my victim, and you can see all the different information. And somewhere in the bottom, we should see our newly created binary that has the power to turn us into root. You can see there's a lot of information. Yes, here it is. Hopefully all of you see it as well. The tool tells us, hey, there is a binary that we don't know, so it's not named as something that is usually commonly present in the Linux system. And it has set user ID enabled, so this is something that you should definitely take a look if you want to become root. So, did the report finished for you, or is it still running? Can you raise your hand for whom is finished? Has it found the binary? I know there is a lot of information to go through, so yeah, it's in the section files with interesting permissions. Hopefully, you would run this as soon as you get into the system for the first time to give you more information about what is happening in the system and how you can take advantage of that. You can see it's also checking the group IDs, which are also possible to misuse, and ACLs, you also know from the class 2 weeks ago, right? The access list, we have covered that briefly. So this is a counterpart of little bit to A that you saw before, right? It was also going through the system and taking, like, remembering all the configurations, all the files, so we can check the state. This is done from the attacker's point of view. It's like an offensive tool. It's supposed to show you where you can look, but also if you run this in your own system, you can see where the weaknesses might be and what to look for. Okay. So, Peace Next Generation, very, very, very nice tool that can be run without installing anything. The other option, and also a very nice resource, is a page which is also in GitHub, but it's named Get the F of the Bins. And it is a list of all the well, not all, a lot of the binaries. I will make it bigger so you can read it. All the different binaries that you can see in the system and how it can be used to do stuff that you aren't supposed to do, becoming sudo, reading files, and so on. So if I select something like base64, you can see that there is a description what it can do. Usually there is also a guide how to do that, how it can be misused, and what you need to do for that. So if you find some of these binaries in the system, also nice resource where to look in order to find what are the next steps in your potential attack. So yeah, it can be used to break out of restricted shells. Anybody has experience with restricted shells? What are those? What are those? So it's an example can be a restricted bash. So usually it's a shell that you can do some things, but other things are forbidden. For instance, in the restricted bash, the user cannot run commands outside of their home directory. So you are limiting the user. Usually, it might be a good practice to only limit the user to in your system to do the stuff that is necessary for them, not just to do anything, right? Because it's easier to control that and check that nothing nasty is going on. So yeah, the base64 binary can be misconfigured, and we will test it right now, how it can be used to access something that we should not. So for that, we will create a very, very secret file called secret file and echo some very secret phrase into it. So, oh, sorry, you need to be root for this. Yes, as root. So be sure that you are root. If you are my victim, you can just type exit as you just saw me do in order to quit the back to root. And then we create the secret file. Just to check, I will list the TMP. And here we have my secret file. Good. Now, what we will do in order to demonstrate how the base64 can be misused is we will set the permissions in the secret file, so only root can read it, right? So it's very, very restrictive. So right now, if I do I'm sorry. Right? Oh, you can see that this is something that I want to achieve. So you should be, after running this command, the secret file should be restricted only to be read by root. So as root, I can read it. I will demonstrate. Right? If I do switch back to my victim, sorry, and repeat the command, I don't have permissions. Good. So we are in the situation that we have a file that the unprivileged user cannot access, and we will see how the misconfigured base64 binary can help us bypass that. So we did our secret file. We set up the permissions so only root can read it. Now we will create a copy of our existing base64 in the system, and during making the copy, we will set the set user ID bit. I will conveniently name the newly created binary as base64 bat to remember that is something that should not be there in the system. So please do that, and once we created the binary that is misconfigured, we will demonstrate how it can be used to read our secret file. So copying the binary and setting the root, the set user ID working for everyone. I will make a pause also for people online to catch up. Okay, so we are done with root. Now let's go back to our victim, so the non-privileged user. Firstly, let's switch to it. And then I've already showed that, but for good measures, let's verify that we indeed cannot read our file. Now what we will do is follow exactly the guide in the GTFO bins, and it says, well, you can use the base64-dec code to read the file that you should not be accessing. So we will use our newly created base64 binary. We will provide the secret file, and we will use the command base64 decode and see what happens. So despite not having access to the file, being specifically restricted because I'm not root from reading the file as we verified before, just because there was some silly bit incorrectly set in the binary, we can access information that should, according all the rules in the Linux system, be forbidden from us. So everybody managed to open that? Cool. Thank you for at least nodding. The feedback is really good to see if everybody is following. Now, you can see that there is a lot. In the GTFO bins, there is a lot of binaries, and a lot of them can do things if they are being misconfigured. So going back to the PSNG, that gives us quite a lot of probability that there will be something in the system that someone managed to misconfigure at some point, right? You can see if I'm scrolling down and I'm like in F, there's a lot more binaries that you can see that can do much more than only file reading. Reverse shells, we have already seen that. Downloading file, setting user ID, and so forth. So very nice resource, especially because it's being updated and keeping up to date. It's often the case that you can find these lists, but they are like from 2005. and now a lot of the things are fixed and you cannot use them anymore. This one in particular is very much updated. Same with the piece. It's still work in progress, so very, very nice, very, very nice resource. Now, we will see an example that when we started doing the class, long time ago, this was actually brand new, and it was discovered and reported, this issue with SUDO, in the middle of our class, so we freaked out and had to fix everything. But then after a while it turned into a nice example that we like to show in the class, and that is a SUDO, that official binary that is accessible in the Linux system, had a really cool issue back in 2019, which under some special circumstances allowed you to run something as SUDO, even though if you did not have that power before. And luckily, this version of the SUDO is still available, so we will try it right now. So please go back to root. Once again, I can do just exit and make sure that I'm in root. And we will, I'm sorry, we will use wget to get this very specific version of the SUDO, which is vulnerable, which has this vulnerability. So use the wget, and then we will use tar to unpack it and store it into /tmp. Okay, once this is done, we need to compile the binary, right? So this is because what we got was just the source code. So we will go into the tmp/sudo 1827. And first, we will run configure. It will take a little bit. All the checks. I realized I decreased my font. Can you guys from the back read it? While it's being configured, any questions so far? Any problems? It seems not. Okay, config finished. I will move to make into which actually compiles it into the binary and installs it in the system. So we can use it. We can use it to demonstrate the vulnerability. Again, there are some warnings. I know we should take care of them, but let's pretend we don't see them. Yeah, just run the make. Did the compilation work? Or is it still running, maybe? Okay, I will wait a little bit. So all of us finish compiling. Oh, is this kind of for me? Or did somebody just leave it? Oh, sorry. Trick or treat. How are you doing? Compilation still going on? Still going on or done? Has anybody finished the compilation? Ooh. Are we reaching the maximum resources in our server? Our tech team is not freaking out, so hopefully not. Yeah, but I was told that you are always watching our servers. So, which little bit of a teaser in the last class, we will disclose how we do that. So if you want to see how all of the things that you are experiencing in the class are being done from the technical side, come to the last class as well. even though it's close to the exam period, it's really worthy. Yeah, Vero might be biased because she will be showing that, but it's true that's gonna be amazing. Okay, have we finished? Still not. Ooh. How about the internet people? I don't have element here. Yeah? 100%. See, this is the funny part. When I try it, and none of you are using the Dockers, it seems like everything will be super fast, and then like 80 of you compiling simultaneously stress test our system. Okay, I will give it like 2 more minutes, and then I will slowly start moving forward. Hopefully, the compilation will finish by that. Can we raise hands who is still in the configure command and who is still in the configure? And the rest of you are in the compilation. Okay, at least we have that. Are we? Okay. Yes, it's broken. Everything is on fire. Okay, so if you manage to finish the compilation, I will slowly move forward. Hopefully, your compilations will finish. What we will do is now again create a setup in our system which will allow us to demonstrate the vulnerability. So by in doing so, we will edit the etc/sudoers. Does anybody know what does this file do? What is the purpose of sudoers? For nice jack-o'-lantern here, sudoers. It's a file that sets up or tells us how can we use the sudo command based on which user are we. So, as you know, sudo will allow us to run something as root without switching to root. And this file specifies in which cases we can do that and how. And because of that, if you misconfigure the file, it has very, very bad consequences. So we will not be doing that manually using our everyday editors, but we will use a tool called vsudo, which is a trick into making you use Vim. But the good thing is that this tool helps us to check that the syntax of the changes we make in that file is actually correct, so we don't screw up. And also, it's doing the change as one atomic operation. So you cannot end up in situations that you change part of that and the rest, then there is some error and everything is on fire. So that's why editing with sudo, with vsudo, is a good idea. For those of you who are not experienced in using Vim, in order to write stuff, you need to press I to enable the insert mode, which is shown over here. And then we need to add this line. The line is my victim all blah blah blah. What does it mean? This line means that user my victim can use sudo in sorry, I screw up. I'll restart. This means that the user my victim can run the tool Vim, this binary, as any other user, but specifically not as root. This is the part that says not as root. Once you input this line in the editor, you need to first quit the editing mode by pressing escape, and then leave the file and store the changes, which is being done by what is it? Colon? Colon. Thank you. Colon, W for writing, and Q for quitting. So this is the change that we want to make. What does it mean is that now when I want to do sudo vim, Oh yeah, so it's actually good because I'm not in the. This is what I like, by the way, about all the language models. They don't care if you make typos; they just work. We should have a language model for terminal. So, in order to demonstrate that the changes that I have just made is actually working, I will switch into my victim. Over here, this is the command. And then I will try to run vim as sudo. It will prompt me for password, which I apparently cannot type. Oh my god. Okay. Brief intermission. Yes, yeah, this is why we use password managers, because we cannot type and remember passwords. So, going back, switching to my victim, trying to run sudo as vim. Sorry, vim as sudo. And this is what I was trying to achieve. It's proof that the edit that I did to this etc/sudoers file actually makes sense, and it's working because the system is telling me, hey, you are trying to use sudo, but you are not allowed to do that on this machine. All of you will have different file over here. People online, you will see something like a hacker lab instead of the BSI student, because that's the name of the host. Okay, so we have created a situation which will allow us to demonstrate the functionality of the broken sudo. How is the compilation? Finished? Anybody still compiling? Oh god. For everyone? Hold on. So
if it fails in the stage where it says the sudoers file is wrong, something like that, the etc sudoers, right? Just move it to some other folder or delete it, and then do make install again, because it will override it.
okay, I will add the
I
command.
can explain why later, but yeah, trust me on that.
Thank you very much. I will over there. So the fix for that would be in here. You are saying in the make file, right? Ah. Mm-hmm. Here. So those of you for whom the compilation failed, do the vsudo, go all the way back to here, and comment it out. Okay. I was in the right place. Okay. So once again, can I ask someone to put it in the document as well, so we have this recorded? If the compilation fails, edit this out.
Mari, what was a specific error? Can you, what is the error that I should see that you mentioned before?
Oh.
So sudo command not found is because we. Mm-hmm.
Okay, so,
Because we deleted.
sorry, this is a little bit tricky. So I will thank you for everyone who pitches in with ways how to solve it. Firstly, we will do the thing which I mentioned specifically not to do, and that is edit etc sudoers this file with your favorite editor. It can be Nano, it can be Vim, it doesn't matter. And the last line should be commented as such. Once I do the changes, I will save them and rerun this command. Oof. So the funny part is, while you are doing that, I will share a story. That this exact demo failed last year, in a different place though. Yeah, and then we spent quite a lot of time on fixing that. One of these fixes was that we were removing the original sudo installed in your Dockers, and this is a leftover of that of the original sudo. So this is why it failed.
Which is a reminder that when you uninstall, like apt remove some package, like not all the configurations files are removed, right? So this means like we remove the package, but the file that is the sudoers was still there. So this is why we are doing this. And remember, if you have questions or it doesn't work for you, tell us, right? Because we cannot know that it's not working for you.
Okay, can someone confirm that the change worked? Oof, thank God. Okay, and the compilation finished with that. Perfect. Now, after doing that, we will yet again edit the sudoers. I assume that after that, it should work even with the sudo because that should be installed with the package as well. So can we confirm? And add the line over here as I was showing before. That was tricky and scary. Okay. Happy Halloween. Spooky season is here. Okay. Once you do the the changes, remember to save it and then switch to my victim and try to run the sudo. So su my victim and sudo vim. So this is the line that we want to see. I hope it's working for you. And now actually how we will go around this error message and exploit the vulnerability in the SUID binary to allow us to open the Vim command. So the vulnerability is in this. Sudo has an option to specify the user ID that we want to run it as. And if we put some weird number in there, in this particular case, -1, it's not being checked for and it just goes through. So if you repeat the command with this, sudo -u hashtag -1, and again, put the password, you can see that no error message is there, and we can freely use this text editor. Alternatively, you can use this big number. Anybody can say why this also works? There you go. And also, I don't remember who was before reporting the error, but I wanted to give you also a keychain. Yes. So, thank you for reporting it. Yes, exactly. I will repeat for the recording. The user IDs are stored as 32-bit integers, and this big number gets converted to -1, so it's actually equal. Okay. Oof. We went through a lot of problems, and the result is that we have opened a text editor. Was it worth it? Like, how does this help us? I mean, text editor, we cannot really do a lot of it that, right? Well, it turns out we can, because Vim is very, very powerful, and it can, among other things, run commands inside the Vim. So in this case, we can extend our command with -c and start a shell. So if I leave and rerun the command with the -c and shell, we now, through Vim, have achieved a working shell. So, okay, nice, working shell. If I do id in that shell, we have a shell that we run as root. So through the proxy of you having to use Vim, we have achieved root privileges in our device, starting as my victim, and all of that was because of someone made a mistake in the code of in the source code of the SUDO binary, which by default is set to have the set user ID enabled. So it's like a chain of events that took us all the way to going from non-privileged my victim user into being able to run commands as root. So this is an example, real world, a little bit old now because it's been a couple of years, but that even these, the source code for these binaries that you would think that is thoroughly checked, and because of the dangers that they can present, you would think that it's like meticulously verified that nothing goes wrong. This made way to a lot of existing systems, including our servers, and made a lot of people scared very fast. So yeah, this is something that that shows that these vulnerabilities and misconfigurations happen even in like places where you would not imagine them, but there are almost always some in the system, and it's very, very nice to look for them and take advantage of them. So what can be next? Once we escalate the privileges to root, we've already seen a couple of things, right? Once you have root, it's easier to establish persistence, so you can use that. You can install something that will keep you access. We might see at the end of the class a tool that is a little bit more automated in finding these vulnerabilities, exploiting them, that is called PwnCut. If not, there is a section in the extra that I refer to. And if you'd like to see and read more about other SUDO vulnerabilities, I've selected a couple of links over here. One of them is from 2023, so it's a little bit newer than the SUDO, but it's not as easy to replicate that. That's why we are still using the SUDO. And also I like it because we have personal experience with actually having to fix those. So there's like a nice attachment to that. Okay. Yeah, so you might remember that 3 weeks ago, we were also talking not only about permissions, but also capabilities. So anybody can remember what are capabilities? Yeah, okay. Yes, so we will remind what are capabilities, and then we will go into a second break before the final segment. So set your ID capabilities. Executable files, well, where this bit is set, but basically same as the same user ID. We will show how this can be used very shortly after the break. So 10 minutes, it's 16:35, so at 4:45 we will continue. Thank you very much, and I'm sorry for the broken demo. Hopefully it was the last broken demo of the day, and everything will go smoothly after the break. So 10 minutes start now. Get refreshed. So capabilities with set user ID, basically it is a similar concept as if the bit is set directly. You can list them using this command in your system. And we will see how this can be misused. Basically, it's the very similar demo that we did in the very beginning. We will add this capability to some of our existing binaries, in this case Python, which is there. So by running this command, careful, online students, you have a different version of Python, so you need to use this one. So by this, we are adding this capability to our Python 3.10, which means that if you rerun this command, you will you will see it over here. So please do. And once we have Python set up like that, we can use the command line version of Python, which we provide the code in using the -c argument. So again, a little bit different for CTU students and for online people. It differs in the Python version. So again, it does very similar thing as the C code in the beginning. We are setting our user ID to 0, which remember it's root, and then using OS system to give us bash. So it's very much, very much the same as the C code in the beginning. Don't forget, as I did almost, to switch to my victim user so we can actually demonstrate the change. So I'm in my victim, I have ID 1000, and now I will take advantage of my Python with extra capabilities. Oh. And I'm root. You can see that this looks a little bit cleaner than before the example with C. I have all the history and everything, but conceptually it's exactly the same thing. Instead of setting the set user ID bit directly in the binary, we modified the capability, but the result is virtually similar. We end up with a privileged user running a shell from a user that was not privileged before. So another way how we can achieve the privilege escalation. And yeah, somebody changed my document. But thank you, because it's time to reveal the password of the day, of the week actually, for the online people. So it is class 6, right? So I will not show something which I should not. So the word of the week to get into the form is hack tool. So I will leave it for a little bit. I'm not sure if we can, at the end of the class, do you have the prompts that were used to generate this? So we can show them, because yeah. Anyway, so hack tool, password of the day. I will close this, and it brings me to a recap for the privilege escalation section. So it's generally a process of getting higher access rights than the one initially granted. Initial granted can mean the user that we have got access to through some exploit. Usually, it's through some vulnerabilities or misconfigurations, like we saw in the SUID. Yeah, you can search for those in the system manually, but there are tools that help us do that and do it faster, so I suggest using those. And I have extra content, but I'm worried that we will not have time for that, so I will move over this, and if we are exceptionally fast, I will show the tool at the end of the class. So we will move to the last part, and that is staying, what I call staying under the radar. Basically, we want to be in the system and stay in the system and being unnoticed if possible. The situation is we managed to get into the host, and we want to stay undetected and do what we want to do inside that. We will focus on two cases of this. One of them is hiding the connection and our IP and the connection properties. And the other one is hiding our actions when we are in the system, what we like processes, sorry, and so on. So yeah, there are a couple of things we can do in order to hide our IP. Probably the easiest one is to use a proxy, right? Has anybody been using proxies? Setting up proxies, sort of? Okay, so yeah, basically it's a system. Selling proxies, good, good point. So basically it's a system that provides a gateway for users to access internet or other hosts and vice versa. So you are sending your traffic somewhere and it's being transferred to the destination that you specify. I'm not sure what this is doing here, sorry. It's a start of the demo that we will do shortly. Can you hear me? I feel like it stopped. Okay. Now it's better. No? Wow. I will try to turn it off and on again. 1, 2, 3. Okay, closer to my mouth. Got it. Wow. Okay, so we have a couple of different proxies, like rotating. It might be a good idea not to use always the same IP to as the final one that is making the connection. So you can rotate this if you have access to a lot of additional IPs. You can, there's a typo here. You can change on time or on request. And basically why we want to do that is that if you are using only one IP in the proxy, it hides your original IP, but you can still tell whoever is receiving the traffic that it's the same connection. So this changing or rotating reduces the risk of actually blacklisting that IP. The problems with IPs, with proxies, sorry, is that you are sending your data through the proxy, so they can see your data. There's usually not a lot of encryption, and it's a very simplistic way to disguise your IP. Nevertheless, we will try it. And we will try it using Nmap and a tool that is called TinyProxy. So first, we will start by configuring our proxy server. Online students will have to do that, again, in a separate machine because they don't have a friend present to help them. So please connect to this, host with root and admin as password. And then once you are in, we will all continue together. So TinyProxy should be already pre-installed in your system. And what we will do is to edit its configuration so we can actually accept some incoming traffic. For that, we need to edit this file. So, I'm sorry, yes. Okay, and you need to do this as a root, and we will edit the etc/tinyproxy and we will add this in the line. So we will allow connection from all the network 172.20/24, right? So edit here. I have it uncommented already. Remember, in Vim, in order to edit, press I to enable the the edit function. So copy that. Yes. Then leave the insert mode and colon WQ to save. So once we do that, we have updated the configuration. We are now accepting the incoming traffic from that range of IPs. Only if the proxy is running, we need to restart it. So some of you probably it's enough to start. If it's running, we will restart it. And yeah, TinyProxy is HTTP proxy. This is a confirmation that is being started. Okay, so for us in the room, we will provide the proxy services for each other. online people, you need to leave the proxy host and go back to your hacker lab. So everybody managed to edit the proxy and start it? Can we move on? Okay, so now, online students, this time for change, you have it more difficult than people in the room. So you need to prepare your victim. Remember that we have the victim computer ready, so connect back to that and switch to the my victim user. Sorry, no. If you are in my victim user, you need to leave it, because we will be TCP dumping, and you cannot do that as an unprivileged user. And then start this TCP dump, because we will be recording the traffic that is coming to us. For people in the room, you will be attacking me, so you don't have to do that. I will start the TCP dump. Actually, I will do it right now. So I will do tmux for that. Is it T? Yes. And yeah, what the TCP dump is doing, I'm listening in the interface ETH0, and I don't want port 22 because I'm connecting to SSH, so I don't want that. I will keep that listening. Leave the tmux with Control B and D. Okay, so this way we have the proxy setup, and we have the victim setup. In your case, the victim is me. Now, we shall be attacking. So, if you want not to attack me, you can also start a TCP dump yourselves, but I think it will be better if everybody attacks me so you can see all the traffic. Oof. Okay, now we need to configure another tool that will actually provide us with the access to the proxy server. And that tool is called proxy chains. Again, it's being pre-installed in your Dockers, and we need to edit it such that it knows where to go and forward our traffic. So this time I'm using Nano. You can also use Vim, and there are a couple of options we can do. Firstly, we can decide if we want to randomly select from the proxy servers we have, or if we want to use them all, or if we want to use all that are available. So by default, you are using the strict chain, which means use all the proxy servers that are in the list and wire through them in like a sequence. If we switch to dynamic change, it will do the same, except for if something is not available, you will just skip it. And last but not least, you can do random, but that requires having at least 2 proxy servers, so you can randomly select from those. We can leave strict, it's fine, and then we scroll all the way down in here, and we don't want Tor, so we will comment this out, and we will put this line that says use, this is for the online people, use this host as our proxy server. For CTU students, you can again share your IPs, select couple of them as your proxy servers, at least one, and put the line which is here. So you can everybody use the same proxy server, but it's much better if you put more of them, so you can actually wire your traffic through several proxies.
Is everyone good?
Yeah,
like
I will make a pause here so we can set it up. I will go to element and select some of yours proxies. So you were sharing your IPs before. I will take advantage of that.
Before you show, let's give 15 more seconds.
Yeah.
So you can type. It's important that you do, right? Remember? Like go type, configure, edit.
Well, you can reshare your, you were sharing in CTU students, sorry. Yes, I will take this one, for instance. Okay, so in my case, that's gonna be HTTP, not the space, just the tab, and then the port that we have opened the proxy on, which should be 88888. Of course, I can do more, and all of you share their IPs, so I will take Kuba's IPs over here. Again, the same port, and so on. Don't remember to save it before leaving. Okay. And last but not least, Seba, can you share your IP so they can use you as a last chain? Yes, and then, so I would like everyone to use this IP as a last one in the chain. So this is Sebastian. He will be our last getaway in our attack. So again, I'm going to scroll all the way down and add this. This is only for the people in the room. People online, you will not have that IP in your network, so this would not work for you. Okay. We have set up our proxy. We have set up our connection to the proxy. Now, how can we use it? Well, we can just add this like before our nmap. So we can do nmap and scan everything. And what it will do, it will start the nmap, hopefully, and then it should chain all the traffic through all the proxies that you have put there in your configuration. And in order to speed this up, I will only put there my IP. So I was saying that you will attack me. So this is it. So CTU students, only attack me, please. I will attack myself as well. Ooh, somebody that I've chosen did not enable the proxy. But if I go to my tmax with the TCP, I should see some traffic. Oh yeah. A lot of you are scanning me. So some of you are going through the correct last proxy, which was 0.0.5. This is Sebastian. 3. Yeah. Okay. We have a confusion here. So, is the TCP dump working? Let me see. Okay, so you can see that I have finished. There is something that was discovered in my nmap scan, and yeah, and what if everything works correctly? I should also only be seeing what was the IP that you were putting? 03. Huh? Okay, so we have confirmation that traffic is going through. There is someone that connects to me directly. Yeah.
Hi. If you see access violation as a result when you are connecting, that means that you are trying to use the proxy to access ports that are not SSL or TLS, and the proxy refuses. So there are some inner things inside the proxy. So for some ports it's going to work, for some it's not, depending on the configuration of the proxy, right? Remember, a proxy can be HTTP style or SOC style, so it depends a little bit.
We are only using the HTTP.
This
is the reason our proxy is restricted to HTTP. There are others that are more bulky that can work with other protocols, but we are only.
Yeah, which means that if you do not speak HTTP, it's going to complain. That's why. So some ports are HTTP, are good. Some ports are other things, and the proxy can say, yeah, access violation, stuff like that. But it's working. Yeah.
Yes, for online people, please only scan this because you have only 3 Dockers in your lab network. So, yeah, that should work as well. So proxy chains, you can actually tie it with additional tools. You don't have to restrict yourself with Nmap. You can use it to access web through the proxies and so forth. But remember, as Sebastian demonstrated here, he can see your traffic, right? So it is not. It's a good idea to change your IP. It's not a good idea to get more privacy or to stop people from sniffing your traffic or to opening your traffic, to monitor your traffic. It's not the solution. So proxies are good for one thing, but not the rest.
Before we move forward, everyone understood what we just did? Like, raise your hand if you understood what you just executed and happened. Okay, no one understood? I cannot see a lot, so if you can raise your hand and keep it so I can move. Yeah, I see a couple of hands. Okay, so maybe Ondra, can you do like a small recap of what we?
Yes, I will do before. So what we did was we forced Nmap using the tool called proxy chains to route the traffic through all the servers that we have listed in the proxy chain. So in order to do the scanning, remember that there might be, when you scan something, you generate a lot of traffic. And if you want to disguise yourself, it's a good idea not to lose parts of your costume. No, it's a good idea to maybe split the scans into different parts. And this allows us to do that. We are using other computers to route our traffic, in this case, Nmap traffic, through them, and then through our final destination. And then the response goes the opposite way. And this way, we can keep our true IP not ever being shown to whoever is victim to our scanning, so they cannot block us in our own IPs. They can block the IPs of the proxies, but not us. They don't know that we are connecting to them. And this way, we can make sure that when we do a lot of scanning, or if we do other types of attacks, our true IP is not being recorded in the target device, in the victim. The downside of that is that whoever is routing throughout traffic can see it. So they can see what we are doing. They know our true IP, and so on. So it has some benefits for us, but it has also a risk if we are doing something that we want to keep very secret and very hidden. I hope that clarifies that a little bit. And proxy chains, this is the tool that we are using. You can use it with anything that generates traffic. So it doesn't have to be Nmap. It can be other tools such as curl, such as ncat, and so forth. So having that installed in your system allows us to route any kind of traffic through the proxy chains. Our only limitation is that we are limited to HTTP traffic because the proxy servers that we were setting up before only handle HTTP traffic. So if you are speaking anything else but HTTP, it will not work for you. OK. Good. Questions from the internet? Hopefully not. If there are any, please stop me. So one step up in the game is to use a VPN. Anybody has their VPN on? CTU actually provides a VPN, as far as I know. So, OK, what does a VPN do? I do have one more thing to share with you. So, who wants to be a proud owner of a green, non-glow-in-the-dark carabiner? You. OK, what's the VPN for?
For hiding your IP address.
And hiding my IP address, what else can VPN do? Anybody else? Here's your carabiner. Oh, sorry. Okay. Okay, so it makes a virtual connection to some other network, and it makes it look like you are part of that network as well. Okay, so I will just repeat for the recording. It will look like you are connecting from the network that you are VPNing to. I'm not sure if that's a word, or and not ADROM in here. Okay, it also often encrypts your traffic, so this is big advantage over the proxies that we showed before. And a lot of the VPNs can actually authenticate the content that you are, like the data that you are sending. That's another big advantage. So you can make sure that nobody is tampering with the data along the way. Yeah, the key question is that not all the traffic from your device usually goes through the VPN. So be careful there. It depends on the VPN. And also there are parts of the traffic which might be tricky, like who resolves the DNS, right? If you are sending a DNS request, how is it being resolved? And last but not least, but I feel like I should mention that, in theory, there are providers of VPNs that are so-called no-log policy, which is a nice word for we are not keeping track of anything that goes through us, but usually there is no way to verify that. So be careful in there. First type of VPNs is called something SSL VPN, and that is the thing that you maybe know you have in your browser. You say, hey, start a VPN. You are trying to access a show in Netflix that is not being available in Europe. You start it, and suddenly you watch from US, right? So you change your geolocation based on the IP to US. So these VPNs, they actually use TLS, but they are only limited to the browser traffic. So every other part of your device traffic is not using the VPN. They are limited to the instance of the browser. And the authentication in those cases are usually done through certificates, which are issued like by third party that is being trusted. So it's not you like generating the security setup, but it's through some third party which issued the certificate. One step further, and this is the type of VPN that actually like tunnels your traffic somewhere, uses a protocol called IPsec. I will go very briefly into this. If you are interested in how does the protocol work, there is extra content at the end of the document which you can go through. There's nice graphs and everything. But the IPsec is the protocol that is being used for the secure communication between the VPN and the client. And it has basically two main protocols which differ a little bit. One of them is called authentication header, and that provides authentication and integrity checks for the traffic that is being transferred, but not encryption. So this is the simpler version of that. If you make sure that nobody is tampering with your data along the way, this is the protocol that is being used. The good thing is that it protects the entire packet, including the IP header, which is a good thing and also a bad thing, because if you are using this behind NAT, it cannot be done because the IP header changes during the translation in the NAT. So this is a limitation. It's very lightweight and very fast. This is a good thing. So if you are in a situation that you just need to verification of the traffic and checking of the integrity of the data, this is the protocol to use. The second option, and actually the most common used in majority of the VPNs, is called encapsulating security payload, and it provides encryption, integrity, and authentication. And unlike the previous one, this doesn't include the IP header, but everything else is being included in the encryption and the integrity checks. And this is something that also protects your data because it's being encrypted. It's possible to use it with NAT, so that is a big thumbs up. But it takes, I know it's an extra overhead. I'm not sure if you have ever used fully a VPN and worked with that. It tends to slow down the traffic in some cases, and it's because of this. There's a lot of overhead in this protocol, in the translation and the encryption, decryption, and so forth. Of course, you can merge these two together and have the full package, and it becomes very, very slow. The ways how this can be done in the extra content at the end of the document, there's a link to the side dish over here. You can go ahead and inspect that. The general message is VPNs are better than proxies in a lot of the things. They are still not 100% reliable in this case. In the case that there are some problems with whoever is handling the data, and it depends on the architecture of the VPNs based on the protocol that they are using. So always, if you are choosing, look deep into that. What are your needs for that, and what is it? Do you need encryption or not, and select based on those. And from VPNs, it's only one step further to Tor, the onion router. Anybody using that? Tor? Yes, the hairy thing here. Yeah. So I have it here, but I want to ask, do you think it's 100% safe? No, it's not. Nothing is, right? So why is it not 100% safe? So for those of you who are not familiar with Tor, I have a diagram in here. Basically, you have the user that connects to the Tor network, and then it's randomly wired through the Tor nodes, and then once it reached several hops, it's part of the configuration. This is the exit node in the Tor network, and then this routes the traffic to the final destination. So why is it not 100% safe? Yes? Mm-hmm. Okay, I will repeat. So the assumption is that every node that is transferring your traffic only knows the source node that is sending the traffic to it, and then the node after, right? And what you were saying is that you cannot really verify that this is the case. We have another opinion over there. Yes. Thank you very much. I have a ghost. So I cannot throw that far. I will, after the class, give you nice ghost keychain. Yes, I will repeat it. If you are using some service that you are logging in, for instance, Google services or something else, it still authenticates you, right? So not everything is fully anonymized. The path of the packets may be, but then the final service that you are looking into still is able to identify you. So it does not provide full anonymity. It may give the impression of the case, but it's not. And yes, the other thing is, which is sort of related to what you were saying, is that it's being encrypted along the way, but the final part is not, right? So once the traffic leaves the Tor network, it's not being encrypted anymore, and yeah, so it's not 100% protection. And the other, theoretical example is that if I'm a service provider and I own the entry node and the exit node, I can match the traffic. So you may think that this is very unlikely. There is a very recent example when was it a security service? No, was it a law enforcement service? They actually start infiltrating the Tor network in order to, they are saying track criminals. That's the news, right? So it's being basically compromised. The Tor network, the Tor provider started to investigating. I'm not sure what was the result. Anybody knows what was the result? I know that the case started. I'm not sure if it's ended, but it shows that even this encrypted and secure network can be breached, and it is breached.
I'm not sure if it finished, but yeah, the authorities were forcing ISPs to sniff the traffic of certain specific nodes, entry Tor nodes, and if nobody's using that entry node a lot, then it's easier to match your IP to the only ones using Tor, so start de-anonymizing some users. It's quite controversial. You can read what Tor had to say about that.
Yeah, there is a link to an article. A lot of the sources for this are in German. This is one of the few that is in English, so I've selected that. If you're speaking German.
It's not straightforward. It's not that they open it or nothing. It's just de-anonymation of IPs, and it's not super easy, but yeah, they did some weird trick there.
Yeah. Okay, so
sorry. Before going there, do you want to, Veronica, tell us about the using VPNs and Tors? Using VPNs and Tors, or
I share in the random great talk by De Grook. He talks about this, but basically, if you use VPN and then Tor, you go to jail. So remember, the order is important.
can you say why?
Okay, because the VPN providers, they know your IP. You're not anonymized, right? And you use you use Tor inside the VPN, and then you are exiting. You're entering the VPN. They know who you are, and then you're exiting the VPN, and they know that you're coming from the VPN. And in the middle, which it doesn't matter, you're using Tor. In the opposite situation is that you use Tor, and inside Tor you use a VPN. So inside Tor, you are protected because your traffic is encapsulated, but no one knows where are you coming from or where are you exiting.
Thanks.
There is more on the talk, which is great. Go and watch it.
And that is being shared in Matrix, right?
Yeah.
Okay.
Sorry, and we have a question from the internet. They were asking, what is the difference between a proxy and a VPN?
Okay. The basic idea is similar. Somebody is taking, like, receiving your traffic. Somebody is receiving your traffic and forwarding it. The problem is the proxy only does that. So they take the traffic as it is and forwards it to the destination which you specify. VPN has something additional on that. Usually the traffic is being encrypted. It depends on the case. It's being usually monitored if there is like a checksum of the payload, so you know if somebody has modified, added something, removed something, and it has different modes. But in some of the modes, it can create a tunnel from your device for some of your traffic to the network that you are connecting to the VPN network. So it's like a better protection. It provides the integrity checks, often the encryption, and this should, in theory, protect your data and protect your privacy. It's more expensive to do that. That's why usually you have to pay for that. But I'm losing microphone. But if you are really if you really care, not only by changing if you don't only care about changing your IP, but to making sure that your traffic is not being altered and monitored, VPN is the way to go.
Yeah. Just remember that, right? VPN is a tunnel, and the proxy will open the connection. Has to, must
open the connection, because it takes the connection and then it's like the game when you tell me message and I tell the message to someone else. I need to know what the message is. Oof. Okay. This is about hiding the connections and IPs. Let's go in the Dockers and see how we can hide some activities in the target host. So, 3 weeks ago, we were looking at a function of Linux that stores the command called history. So you can access it into 2 ways. Firstly, you can echo what is called the hist file, which is the file where the commands are being stored, or you can use the command history, in this case history 5, to access the last 5 commands that were used in the batch. So I will stop this TCP dump, and first we'll try the history file. You can see that last thing was exiting from the my victim. By the way, you can also do. Oh, sorry. I'm connecting, copying wrong thing. Yes, this tells you where is it located. In this case, the hidden file bash history. Okay, so when I do the history 5, it tells me the last five commands that were used. In this case, you can notice that it also includes the file that triggers this. Sorry, the command that it triggers this. We can simulate the same thing by cutting the hist file and then use tail command to only take the last 5 lines. So I was saying that we can simulate the same behavior, but you can see that it's very much not the same behavior. And my question is, do you know why is it different? Why does the history tells me something else than the file that should store the history? The reason is that usually the bash history is being updated when you log out. So the commands are stored in in memory, and once you log out, it's being dumped into the file. We can force actually storing it immediately by editing the bash rc file. If we add this command, we will append everything right away. So if you want to make sure that everything is being tracked immediately, this is the way to go. Now, later on, we will see what happens if this is not enabled. But our goal is to hide our commands, right? How you hide our steps. So how do we delete stuff from history? That's the question. And history has a command called version of the command with -d, and then you can say how many lines of history you want to wipe. So if I do history, you can see that there is currently 757 logs or commands stored in there. And when I do this, you can see that I've removed some of them. So yeah, you can also put a range. So if you have a specific range of commands that you would like to wipe, you can do that by setting start and stop IDs of the commands. And this is good. We can remove stuff, but maybe it would be better not to store it while we do or perform the commands. And we can do that by adding this part after our command in bash. So in this case, I want to use echo to just print something in the screen, but I don't want this to be recorded in the history. So I will add sorry, I will add this part which says, hey, delete the one line from the history. So the command works. I've successfully outputted the word in the screen, and now you can see that it's not being recorded in my history file. So this is a way. If basically the TLDR is, if you include this part after everything you run in bash, it will not be recorded, and you can use this to kind of stay hidden from someone who would inspect that would go and inspect the bash history, which is something people do. Like if something weird is happening in your system, you would see you would go and see, hey, who was doing stuff. We actually did it 2 weeks ago when we were evaluating all the changes in the system. We were looking at history, right? So it's something that can tell you that something weird was happening, and this is one of the tools. Now, assuming you forgot about all this and you want to leave the system and you're like, oh shoot, I didn't take care of that. Like, can I still save myself? And the answer is yes. If you are SSHing somewhere and you execute kill-9 space 0, it will kill the connection without storing the dumping the history in the file. So you can still do it like instead of appending this part for every command, you can just do it at the end. Now, the only problem is if this line has been used and it's being dumped right away, the kill-9 will not work. So it's better to take care of that immediately. Other option would be just say, hey, do not store anything in the history at all. And you can do that by just saying that the hist file is null. It's not existing. So this way we can like wipe it once for all. OK, that is being the history, but it still doesn't help us in other things, such as running processes. Again, remember when we were looking for intrusion in our system, processes were one of the things that we were focusing on. Like, hey, what is running? And today we have seen a lot of things that actually spawn processes and leave them in the system, such as the remote shell, such as some of the other persistent techniques. So it's good to being able to hide those, or at least somehow hide those. So for that, we will again use our trusted myVictim user. So, and then we will do this line, which says execute nmap with these parameters, and execute it with the name. In this case, surely there's nothing to worry about. So when I do this, and then someone else, I will do list of the processes. You can see over here, I will try to decrease a little bit. Over here, there is a user, myVictim, that is executing what, well, surely nothing to worry about, and with some parameters. Now, OK, this is still looking suspicious, so it might be better to just put no name there, right? So if I, instead of the funny name that I tried to come up with, just use empty quotes, this will just put nothing as a name of the process. The only problem is, and this really doesn't solve it, that the rest of the parameters are still there. So it's not 100% reliable. Can you think about a way how to make this more or better? So I would also hide the parameters of the command. What if I have a, let's say, I could have a binary that runs it, right? And then hide the name of that. I could run it through another file that has the parameters inside it, so it's not in plain sight over there. So this is a simple way how to achieve that, but it's not 100% reliable because you cannot really hide the parameters of the commands that you are using. And we can work around that, again, by editing the bash.rc file. But this is a little bit tricky and a little bit complex. So what we can do is basically hijack the output of the, in this case, ps command. So we can say, hey, when someone uses ps, just replace the output or remove stuff from the output. So if we take this, and the tool to hide in our case is nmap, we can say, whatever line in the output of the tool ps says nmap, just skip that line. So we completely remove it from the output. Again, it works for ps or for every command that we specify in here, but if the defender or the administrator of the system uses something else, we are not really being protected. And one bad probably last thing before going to the assignment is a way how to do almost invisible connection. So there is a set of parameters in SSH that can help you not be almost not be detected that you are being connected to the system, and it's by using this and the bash I. So this will make your connection a little bit weird. You can use it. You can use it from your terminal to your host to your Dockers in our server. Just remember that you have assigned a port, so you need to replace that. Online students, you can connect to your victim device. So I will show this in the terminal. Oh, sorry, I forgot a T. So you can see that I'm being connected. Oh, I forgot my password, sorry. This seems to be happening a lot today. Yeah, I'm not sure if that helps. Sorry, one more time. I think I've lost my luck. Okay then, sorry about it. I have to skip it then, because for some reason I cannot make the connection. Can you, maybe people in the internet, tell me if it works for you? Okay, so this is a to-do for home. Try it. The command should be fine. So I will explain what it does at least. This command will hide your presence in the system from everyone that is using V or users. It will not help with nstat because it checks the port, so it will still show there. So we could just repeat our approach from previous step and try to hijack the output of the nstat. Similarly, that I was showing for the PS before. So these are several steps that you can take, like extra care to protect you from being discovered in the system. You can see that it's very hard, and to do it like full scale and 100% reliably, because it depends usually on the tools that the system administrators use for monitoring. But sometimes it's good to think about, okay, can I do the extra step to increase my chances of not being protected, not being detected? Yeah. So I have 5 minutes left. We have the assignment coming as well. But I want to remind everyone sitting here, because unlike the people online, you will not just switch off your Dockers. Please make sure to remove all the stuff from the Dockers that can be harmful and lead to someone accessing it. So first of all, delete the user, my victim, that we have been using. Also, it's good if you uninstall the bad sudo. I believe that if not, we will also force this in the upcoming week. Remember that we were creating something called base64, so also remove that. Remove the capabilities from Python that we did. And if you did any changes to the bash RC, also remove that. If you have any remaining remote shells or encats, also clean it. and we didn't do any cron jobs, so you don't have to do anything there. Last but not least, if you don't want other people using you as a proxy, which I suggest you do not, if you are not getting paid for that, just stop the proxy service in your Docker. Again, online people, you don't need to care about that, because once you stop the class 6, everything will be wiped. OK, so this is a cleanup. Please make sure not to skip this part. I know it's late and you want to go home, but it's important not to leave traces in our system. As we could see today, it can lead to further and future exploits. And I will pass words to Martin or Vero to explain the assignment.
OK, so assignment opens at the same time as usual. This is about attacking and applying everything that you saw today. So you will have to gain access, you will have to gain persistence, and then you will have to elevate privileges, and hopefully you have fun in the process. Last time, in the previous assignment, between the second and third place, there was like 2 seconds or less than 2 seconds difference, so that was very crazy. So hopefully this is going to be a little bit more challenging. As usual, be patient, try to use your imagination. Sometimes the obvious thing is what is happening. And we are available on the private chats if you have questions.
Oh yeah, and there's also a new challenge in the Strato Cyberlab, so that's for you and also the online people. You can play there. For you, it's just for practice. And what? Oh, so they can see me. OK. It's called Jump Around, and it's about what you learned today. There's some privilege escalation, and I'm not going to say more, not to spoil it for you. But read the titles and descriptions. There can be some hints for you, and have fun.
If I'm not mistaken, it's labeled as hard, so if you thought that the previous challenges were too easy for you, this should be more of a challenge.
But it's difficult to label the difficulty, so if you can and provide some feedback about the difficulty, maybe we can change it. Maybe it's not that hard. OK, and before...
One more thing, and remember the Strato Cyberlab is open to everybody, even for CTO students, and we are super happy if you want to contribute, maybe make your own challenge, right? If this is too easy for you, you can go to the repo, create your own challenge, and see how other people can solve it.
Any more comments?
Yeah, were there some questions?
Oh, yeah.
Here?
OK, thank you. We will look into that and ideally either tell you how to install it, uninstall it, or do it in parallel for everyone, so we make sure that the Dockers are safe. Yeah. Any more questions?
Can I add one more thing?
Yes.
Yeah, regarding the last class, again, thank you everyone who did a survey, remember with the honeypot or a real system. I didn't have time this week to send you emails whether you interacted really with a honeypot or a real system. So sometime next week you should hopefully receive those emails. I apologize, I was pretty busy this week, so yeah, that's it for me.
Yes, and as always, please provide us with feedback. We try to improve the classes. So if you liked something or didn't like something, please let us know. We carefully inspect the results. Thank you very much for attention. Happy Halloween, happy Diwali if you are Hindu, and see you next week.